All right, everybody, and welcome to the Daily Space Weather. This is a YouTube exclusive. Today we'll be talking about umbral growth and migration and actual climate information. The growth and migration of Umbral associated with sunspot 2804, which is that northern sunspot group, as the group in the south shrinks, sunspot 2805. The likelihood for solar flares has gone up a bit, and there still is a significant possibility for additional coronal mass ejections. We actually are going to show you yet another one that's occurred in the past 24 hours. Here's the intensitygram. The last slide was the colorized magnetogram. Here's the intensitygram, and you can see the migration of that umbra. Zoom in a little bit on that. Again, likelihood of solar flares has gone up a bit. And we're actually seeing background B-class X-ray flaring now. It's sort of an ongoing X-ray flux in the B range. So here are some helioviewer movies. And you can see Venus down there in the lower right. And there's that coronal mass ejection headed off to Earth's east. And we would expect that one to be another miss. Does not look Earth-facing. Great view there from the LASCO C2 and C3. So here's a close-up of the magnetogram of sunspot 2804. Fantastic view of that. And you can see the fields are spreading apart a little bit, and we often see that before we see not coronal mass ejections. We often see the field spreading apart before we see solar flares. So, once again, I would remind our viewers not to get solar flares and coronal mass ejections mixed up. Solar flares are X-rays, high-energy photons. Coronal mass ejections are protons. Fantastic close-up there of sunspot 2804. Here's a full disk view, and you would notice some plasma filaments on your lower right there, the southwestern limb. There are also some additional filaments in between the Earth and Sun. And those do have the possibility to eject in the coming day or two. We'll keep you posted if it happens. Next, I'd like to thank our patrons, the true source of funding for the content, as we make just this side of nothing on YouTube. So please tell your friends and foes about the content. Please consider becoming a patron at patreon.com/smashamash. Thanks again, patrons. You are increasing the probability that these videos will continue to exist, be publicly visible, and free for everybody to view. Here's a diagram of the solar system. There's where things will be in a week as we approach a full moon in the next couple of days. There's where things will be on March 4th. Here's a star chart, and if you're up before dawn, you may see the moon setting in the western sky. The radio flux has jumped up to 81 solar flux units. And for you new viewers out there, the 10.7 centimeter radio flux, discovered in 1947, is a measurement of the chromospheric and coronal radio output. So this is proportional to sunspot number. And to put it in context, there is the 1 year chart. The black line up there is the 10.7 centimeter radio flux, and the red line at the bottom is the sunspot number. So now back up above 80, and you can say we're back out of solar minimum conditions, having crept back into solar minimum conditions here for several weeks. Now back out of that. And there is the context through the last solar cycle, cycle 24. Welcome to cycle 25. Next, we're looking at volcanoes erupting and Strombolian eruptions happening once again at Mount Etna. So a Sicilian volcano erupting in epic fashion once again. Strombolian eruptions are eruptions involving lava fountaining. Suwanosejima is exploding also in the Ryukyu Islands. It's producing a 7,000-foot ash plume. Mount Raung has stopped erupting, but there's still a volcanic ash cloud above there to 14,000 feet of altitude. Mount Ibu exploding. Flight level 070, it's a 7,000-foot ash plume. Sinabung, which is the deadliest volcano on Earth over the past couple of years, exploding. Flight level 130, a 13,000-foot ash plume there. Semeru exploding. Flight level 130 there as well on East Java. Dukono, flight level 070. Its volcanic ash plume is 7,000 feet above sea level. Please don't fly your hang glider over that caldera. Popocatépetl down in Mexico exploding. 21,000-foot ash plume. Fuego exploding. 16,000-foot ash plume. And Sabancaya is reminding us as it explodes. Intermittent emissions have created a 25,000-foot ash plume. Please do not attempt to pole vault the caldera. Next, we're going to look at earthquakes. What have I done? What have I done? All right, next we're going to look at earthquakes over the past 24 hours. And we see an ongoing earthquake swarm at Iceland. Let's zoom in to show you the location of that. It's all in the southwestern corner here. Some actually occurring very close to Reykjavik. That's a 4.6 magnitude. Here is a 4.6 magnitude as well. And leave us a comment if you felt those earthquakes. If you're viewing from Iceland, thanks for tuning in. So no major quakes over the past 24 hours. A 4.7 magnitude at over 169 kilometers depth struck western South America. A deep quake struck Russia at a 4.9 magnitude. There's a location of that one north of Japan, actually closer to Japan than to most of Russia. One of the largest of the past 24 was a deep quake at Guam. Let's check the location of that. And leave us a comment if you're viewing the video from Guam. Did you feel an earthquake? Anyway, that's where that occurred, north of the island of Guam. Small deep quake struck the Caribbean there at Dominica, a 3.6 at 118 kilometers depth. 5.2 magnitude quake struck the South Pacific Ocean near the Pacific-Antarctic plate boundary. Another small deep quake in the Caribbean. 4.2 magnitude deep quake in Afghanistan. So pretty calm as far as earthquakes go. I would invite all of our viewers to check out our own website. We saw the writing years ago on the wall. The writing on the wall, we saw it years ago. And so we created our own website because we realized that we would need to have our own website in order to do what we want on the internet. We've got all of our links to our social media there. As big tech self-destructs, our web ring grows. We've also got links to our forum and our merch shops. Please consider picking up some merch, supporting the channel by becoming a patron. You can find links to that there on the homepage as well. smAshomash.com. And if you're viewing on YouTube, please don't forget to press like and subscribe, as the place is on fire and we can't afford a fire extinguisher. So please press like and subscribe so I don't have to keep using my super breath to put out these fires. We need your assistance to get the content out there. Thanks again to our YouTube subscribers. Thanks to our new subscribers, as well as our loyal viewers. And if you're viewing on BitChute, don't forget to check out YouTube as well, as there is exclusive content across platforms. YouTube.com/smAshomash And don't forget to check out our playlists as well, youtube.com/smashamash/playlists, in which you'll find our latest playlist, Do One Thing. Here's a video from just yesterday. I'll play you a clip.
Only in your comfort zone. You're not learning jack.
So get out of your comfort zone, folks. That was the message. Go watch the video if you haven't. youtube.com/smashamash/playlists. And thanks to our new BitChute subscribers as well. Let's do a cosmology segment. So, when we see plasma traveling through space, we see plasma traveling through space like train cars, connected by these narrow, perhaps filaments. And this all has to do with the orientation of the magnetic field from the object from which they came. So this is an astrophysical jet here, coming out of something like perhaps a supermassive black hole. I'm not exactly sure which object this is, but the poloidal fields of these objects are known to produce jets. And the structure of that jet is all dependent on the orientation of the magnetic field proportionally speaking to the outflow. So if you have an outflow that is perfectly aligned to the jet, you'll have a very solid jet. If you have an outflow that's partially misaligned from the jet, you'll have a less organized jet like this one here. And if you have an even more misaligned field, you won't have a jet at all. You'll have more of an irregular outflow. So this is an interesting article here. You can find this on phys.org in the Astronomy and Space section. It turns out, who knew? Most people that view our channel probably knew that the plasma aligns to the magnetic fields. So, quote, we found that the outflow/magnetic jet misalignment is a plausible key process regulating jet collimation in a variety of objects, from the sun's outflows to extragalactic jets. So it's kind of important, folks. And we see lots of astrophysical jets. If you're familiar with our merch shop, you may notice that one of the first pieces of merch that we created was some massive radio jets from massive radio galaxy Cygnus A, otherwise known as 3C405, which has some massive jets. And it's an interesting galaxy, to say the least. You can find links to that at smashamash.com at the smAsho store. So this is in a lab experiment here. We notice that we see these different types of shockwave orientations based on how misaligned the magnetic field is. If it's off by 10%, you'll get a jet shaped like this. If it's off by 45%, you'll get a jet that's barely a jet. As we see plasma traveling through space in a train car-like fashion. Next, we're going to pick a random number and look at a random object. Although I think nothing in space is, nothing in the universe is random, folks. What do you think? Leave us a comment if you think things are or aren't random. Today's random quantum number is 427, which will coincide with some object at the Neil Gorell Swift Observatory. 427. What could it be? Well, it turns out that it's low-mass X-ray binary 4U1246-58. So most likely an object within the Milky Way galaxy, or perhaps in one of the Magellanic Clouds, but more likely in the galaxy. 4U1246-58 is a consistent X-ray source, as you can see here in the upper right, over the past 16 years. Here's the daily chart. Quite a consistent X-ray source. Let's have a look at it. And we'll look at a couple different wavelengths here if we are able. Here it is on Simbad. Let's go to Aladdin Light to look at additional layers. First, we'll take a look at the 2-mass, which is infrared light. Not a lot showing up there. How about an optical? It looks like it's in a pretty heavily populated portion of space, folks. Does it show up on the multi-mirror project? Nope. How about the Chandra? And indeed not. In any case, that's today's random object. Number 427, low-mass X-ray binary, 4U1246-58. somewhere in there are two massive objects, two star-like objects, one orbiting the other one, producing a bit of photonic activity. Let's talk about the Parker Solar Probe. Who knew that the Parker Solar Probe was capable of more than expected? Well, not many people did, obviously, but it turns out that it is. Now, what you're looking at here is the WSPR instrument on the Parker Solar Probe, and these streaks you see are cosmic rays striking the probe. But the most important thing is this dark area right here. What is that? That's a surface feature on the planet Venus. Now, the Parker Solar Probe does gravitational assist slingshot maneuvers around Venus in order to maintain its orbit at various times throughout its mission. What it was not expecting was to be able to see surface features on Venus. It turns out that this instrument may have near-infrared capabilities, which will increase its capability. Who even knew? The people that made the instruments didn't even know. And they're returning to the lab to determine whether or not the WSPR is able to see near-infrared. So they expected to only see clouds, but the camera was able to see Aphrodite Terra, a low spot on the planet's surface, the thermal emission of the Venusian surface. So super interesting there, and we'll definitely talk more about the Parker Solar Probe at a later time. I'll let the article scroll here. You can find this one at phys.org's Astronomy and Space section as well. That's today's cosmology segment, and let's move on. You can see the X-ray flux of the sun here has been in the B-class range almost entirely for the past about 16 hours. A couple minor B-class flares. Again, the likelihood of larger flares has increased with the consolidation and the migration of the fields associated with sunspot 2804 in the northern hemisphere. We don't see any proton flux events here over the past months, and despite seeing that, quote, glancing blow, end quote, of that extremely minor coronal mass ejection strike, no proton events. So it was as minor as it gets. You could barely even call that a strike, although we were incorrect in forecasting that it would not strike at all. Here's a real-time solar wind, and we've brought up the 7-day chart here of the real-time solar wind, and you can see this coronal hole wind stream, which kicked up toward the end of the day on the 19th, made it all the way into the around 630 kilometers per second, I think, was the high point of that coronal hole wind stream. And now I've lost control. Here we go. But it was over 600. It hovered around the mid-500s for most of the coronal hole wind stream, and now it has subsided. Current conditions are solar wind velocity around 450 protons per cubic centimeter, solar wind density 6.88 protons per cubic centimeter. And that coronal mass ejection strike, here was the signal from that. Barely anything. Just a little bit of a signal there in the temperature data. Lower temperature plasma than from the coronal hole wind stream. KP index has come down off of another period of geomagnetic unrest, and we can expect ongoing calm conditions here in the KP index. And for you new viewers, the KP index is a measurement of global geomagnetism. Spent 12 hours late yesterday and early today in geomagnetic unrest conditions. Here's 4 hours of data of what the magnetosphere would look like if it were visible. And we're looking at a model here based on the space weather modeling framework. Again, 4 hours of data. Magnetohydrodynamic pressure. And we can expect to see this further subside as we move into calmer conditions. Here are ground magnetic perturbations. as the solar wind creates induction and affects the Earth's magnetic field. So what we're looking at here are changes in the Earth's magnetic field, otherwise known as geospace delta B. Since that refreshed, I'm going to let that play through. We don't edit the videos, typically if they're a daily space weather video, to get them out as quickly as possible. So again, make sure you subscribe and see when we put up new content. We put up supplementals when things happen. That's 4 hours of data of ground magnetic perturbations during this geomagnetic excursion. Here's the GOES magnetometer over the past 3 days, and we see a wild spike there just after midnight. And this all has to do with the amount of plasma in between the Earth and the Sun largely, as well as things like coronal holes, and the power of the north and south solar polar fields. In any case, the GOES 16 measures at the F ionosphere layer. We'll show you where that is a little later in the video. So there's 3 days of GOES magnetometer data. Let's take a look at the heliospheric current sheet. This is the top view ecliptic plane field plot, part of the National Sunspot Observatory, and this data is derived from 51 ground-based magnetometers here on planet Earth, as well as magnetometers at Lagrange point 5 stereo A and Lagrange point 4 stereo B, which are those little plus signs there. Earth is solidly in the South Pole current sheet shown in red, and I would anticipate us to remain there tomorrow. North Pole current sheet on the way. Here's a line of sight plot. This also shows you the Sun's B field, which is that blue series of potential field surface source lines. As well as the solar magnetogram. We do have another coronal hole swinging into the Earth-facing zone here. And again, there are plasma filaments in between Earth and Sun, which is why we are extending the coronal mass ejection watch. And if one happens, we will make a video to cover it. Keep in mind this data is 2 hours and 6 minutes old. And here's the magnetic field plot of the Sun's atmosphere, the solar corona. It'll show you open potential field surface source lines in either black or purple, depending on their location, and closed ones in pink. It's a chaotic place. We show it daily. Here's the diagram I was talking about. That red F over there on the right, that would be the F ionosphere layer where the GOES 16 makes its measurements. If you have to pause it on this screen to help yourself understand the layers of the atmosphere and the penetration of electromagnetic radiation into said atmosphere, feel free. Here's another diagram showing Van Allen belts, the radiation belts that surround the planet, as well as altitudes of spacecraft in miles. We show it daily before we talk about electrons. Electrons can charge up spacecraft, and we see minor charging hazards here. The electron flux has moved back out of warning levels, having reached over 20 times warning levels yesterday. Minor charging hazards there, as you can see, over Mexico and the Central Pacific there. This right here coincides with about 22 times the electron flux warning levels, as this is a magnitudinal graph, so this is 10 times this, which is 10 times this, which is 10 times this, and so on. Electron flux back into non-warning levels here. There's the 1-year chart of that to put it in context. Here's a visualization. This will show you where GPS errors will occur. GPS errors are most likely to occur around the equator, and we see some of the biggest, some of the most significant electron content forecast here. Very dense regions of electrons formed. You can see that turning red there. That would coincide with GPS errors up to thousands of miles. So some significant electron fluxes there happening. Very dense regions of electrons, as you can see, making it up to 48 times 10 to the 18 electrons per meter squared is what that is. It's a two-dimensional graph of the entire air column from your GPS handset all the way up to your GPS satellite. You can see some large, dense regions there over places like the Western Pacific and the Central Pacific there, south of Hawaii. And those are the highest we've seen in a long, long time. And you can see here the forecast is for this to dip back down. No argument from me there. And the forecast is the green boxes. The observation is the yellow diamonds. Here's a visualization of the ionosphere, since this is where the GOES 16 makes its measurements. We try to tie the data together. And if you're wondering why we show these specific slides every day, it's because it took us months and months to figure out which slides to show, as we're interested in immersing ourselves in the data and helping our viewers to understand the physics, if at all possible. In any case, that's a full day of ionosphere data. The ionosphere looking quite normal here. Latest image coming in at 10:30 Universal Time. Let's talk about climate. The Gulf Stream comes up like this, folks. When the Gulf Stream encounters fresh water, the fresh water affects the oscillation of the Gulf Stream, and it causes it to stagnate and not continue to warm places like the UK. The UK is a canary in the coal mine, in that when we see the Thames freeze, and we did this winter, it is an indication that there has been a breakdown of the North Atlantic oscillation. So as the Gulf Stream comes up there, it normally warms places like the UK and Iceland. It's been doing less so this winter, and it has to do with fresh water. So what you're looking at here is a salinity chart. The redder the water is, the saltier the water is. And since water that is less salty is less massive, it has a tendency to float in pools on the surface. So we can see right now that a lot of fresh water has been sort of passing through the Canadian archipelago up there south of the Arctic Circle and ending in the Beaufort Gyre. Now, this is not a fully understood process, but this does not mean that the planet is warming, folks. And the Thames freezing is not an indication that the planet is warming. So this article here is once another phys.org article. In the Earth section, record high Arctic fresh water will flow to Labrador Sea. Yada, yada, yada. I'll let the article scroll so you can read it if you like. Not an indication of global warming. Although global warming alarmists may incorrectly assert that it is, it isn't. And we're going to show you where the fresh water comes from. You'll probably be able to figure it out. But here's our next slide. So we're looking at sea ice thickness, and we've been told for decades that we would see no sea ice at all. Pretty fluctuating levels of sea ice over the past several years. We have not seen the Arctic ice-free. So here's some imagery of the Arctic. Doesn't look ice-free to me. I see areas there right around the geographic North Pole where the ice is up to 4.5 meters thick. Those red areas, as well as some very thick ice around the east coast of Greenland and so on. Here's the graph of sea ice volume as of yesterday. And you can see it's just in the lower part of the sea ice volume range. You can find that information at the Danish, what is it? polarportal.dk. And you can probably guess where all of that fresh water is coming from. It's coming from massive amounts of snow. So here's the snow water equivalent. And this is on globalcryospherewatch.org. Here is the snow extent, which has now finally moved back within the multi-decadal range there, which is those blue lines. And here is the snow mass balance for the Northern Hemisphere. And the last 3 winters saw 2 standard deviations above normal snow mass balance. The blue shaded area would be the 30-year average. And you can see how much snow is there. And when the snow melts, we see a lot of fresh water, which is where the fresh water is coming from. It's not because the Arctic is melting. It's melting and we're going to die because the planet's so hot, which won't kill you anyway. But in any case, let's get back to meteorological data. Here are the jet streams. And check out the kinked up jet stream off the coast of California. We've got part of the jet stream blowing backwards here over the eastern Pacific. And when the jet stream's blowing east to west, that is what we call backwards. Tripled up jet stream over the North Atlantic there. Extreme meridional jet stream flow, to say the least. Check out the doubled up jet stream over southern South America. Extreme bends everywhere. Here are the jet streams of the eastern world. And we see some extreme kinks over Australia once again. And we do see some backward flow here over the western Pacific and the Indian Ocean. Jet stream blowing east to west in those areas. Next, looking at lightning. We show it daily. I'm interested in where lightning's striking, so I look at lightningmaps.org when I hear thunder, for example. And we're seeing a lull here over the past 5 days of lightning. Very low amount of lightning strikes over the past 5 days. Interesting. Here are pressure cells on windy.com. Massive anticyclone here over the Pacific Ocean. You can see that huge clockwise rotation there, as well as high pressure over most of the U.S. And here's where the GFS forecast has pressure cells being at tomorrow noon Eastern Time. Here's the cloud layer. It's too dark to see it, but we report it daily anyway using the NASA GOES Interactive Weather Satellite's shortwave radiation map. Considerable low clouds here over the North Atlantic once again, as well as the northern part of the Gulf of Mexico. Again, there's water vapor. And we see some extremely moist air moving into northern Idaho and northwestern Montana. How about a U.S. Doppler radar map? Some heavy snow falling in eastern Colorado. And we won't zoom in on any areas. We'll thank the smAsho team for tuning in. We'll remind you to click our links and support the channel. Perhaps consider becoming a patron. Don't forget to press like and subscribe over on YouTube. And if you're viewing any place besides YouTube, make sure you go view YouTube. There is the most exclusive video content there of any platform. And we've got bonus features. And the first one is the solar intensity gram. Here's a close-up of sunspot 2804. And you can see that leading umbra has continued to grow. It is still a beta class. And again, there is still a significant possibility of solar flares from that. There's the colorized magnetogram. Trailing umbra significant in size as well. The leading umbra is practically the size of the Earth. And here are some more close-ups of that on HelioViewer. Here's 94 angstroms. Fantastic view of sunspot 2804. And here's 171 angstroms, my personal favorite. And if we see additional activity, we will create another video about it. Thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. When you're staring at the sun, don't drink. But if you do drink, don't drive. And may that solar wind be at your back.